Hello students, in this video we will discuss the exercise 5.7 of class 12th NCERT. Okay, so this is second order derivative. So in this chapter we will discuss second order derivative. So in this is the part 1 of exercise 5.1. So in this video I will discuss the questions from question number 1 to question number 5. Okay, and in the coming videos I will make the part 2, part 3 and will complete this chapter and will solve every questions. Okay, so we'll start with the first question. So what we have to do in this chapter, we have to find the second order derivative of the function given from exercise 1 to 10. Okay, so we have to find the second order derivative. Second order derivative, you know, right? If y is a function, y is a function of x, y is a function of x. So first I am finding dy upon dx, that is called first derivative. So first derivative is nothing but dy upon dx. Dy upon dx is first derivative. Okay, and if I am deriving again, if I am deriving dy upon dx with respect to x again, then I will get d2y upon dx square. Okay, that is nothing but derivative of dy upon dx with respect to x again. Okay, so this is the concept. Like we have to derive the second time. We will solve the question, then you will understand easily. So we'll start with the question number 1. Question number 1 is x square plus 3x plus 2. Okay, so in question number 1, we have to function is given as y is equal to x square plus 3x plus 2. Okay, and we have to find the second order derivative. Second order derivative means d2y upon dx square we have to find. Okay, so first I will derive this function with respect to x. So if I will derive this function with respect to x, so I will write dy upon dx and derivative will be, you know, we discussed in previous videos, x square derivative, or I will write 1 x square plus 3x plus 2. Then you will use the algebra and you will separate, you will find the derivative of each term. So derivative of x square plus derivative of 3x plus derivative of 2. This is the first question, so I am doing step by step. From question number 2 we will skip few steps. Okay, and then x square derivative, you know, using the x to the power n formula, n into x to the power n minus 1. So x square derivative will be 2x. Okay, plus derivative of 3 in 3x. So 3 is constant, so 3 will come outside, and derivative of x with respect to x is 1. So I will write 1. So 3 into 1 plus 2 is constant term. So you know that constant term derivative is 0. So this term will be 0. So finally you will get 2x plus 3. So dy upon dx, what you got? Dy upon dx will be 2x plus 3. So these all things I am erasing and I will write the solution here. We got 2x plus 3. Okay, so dy upon dx we got 2x plus 3. Now I will do double derivative. Double derivative symbol is d2y upon dx square, and meaning of this is derivative with respect to x of dy upon dx. Correct? The meaning of this d2y upon dx square is derivative of dy upon dx with respect to x, and what will do d upon dx, and in place of dy upon dx we got result as 2x plus 3. So I will replace this dy upon dx as 2x plus 3. Okay, and in the same way I will apply the algebra of derivative. So first term derivative plus derivative of second term. Okay, and derivative of 2x will be 2 and x derivative is 1. Correct? So this will be, you can write as 2 and derivative of x will be 1 plus derivative of 3. 3 is constant, so derivative of 3 will be 0. So 2 into 1 plus 0, 2 plus 0, that is 2. Okay. So in this way we got d2y upon dx square as 2. Okay. So this will be our answer. d2y upon dx square is 2. Okay. So in this way, this was the first question, so I discussed in detail. Okay. So now we'll move to the second question. Second question is given as y is given as x to the power 20. Y is given as, second question, y is given as x to the power 20 and we have to find the double derivative. So we'll do speedily, correct? Because we discussed in detail the first question. So first I will find dy upon dx. So dy upon dx using the formula, which formula? X to the power n. Derivative of x to the power n with respect to x is x into x to the power n into x to the power n minus 1. So 20 and x to the power 20 minus 1. And 20 minus 1 is nothing but 19. So 20 x to the power 19 is dy upon dx. Now we will derive again, we will find d2y upon dx square, that is nothing but derivative of dy upon dx with respect to x. So in place of dy upon dx I will write as 20 x to the power 19. Okay. And 20 is constant. So 20 is constant. So 20 I will take outside and derivative of x to the power 19 will be 19 x to the power 19 minus 1 using the same formula. Okay. So 20 into 19 is nothing but 380 and x to the power 19 minus 1 is 18. Okay. So this will be our answer. So answer is 380 d2y upon dx square is 380 into x to the power 18. Okay. So this is our second question. Okay. So now we'll move to the third question. Third question is y is given as x into cos x. Y is given as x into cos x. So third question is y is given as x cos x. Okay, and we have to find d2y upon dx square. Okay, means double derivative. So first I will derive y with respect to x. So dy upon dx will be derivative with respect to x of x cos x, and this is nothing but u into v formula. Two function, x is a function and cos x is another function. So here you will use u into v formula. So you know the formula of u into v. I will write the formula here. So derivative of u into v. Okay. So u dv upon dx plus v du upon dx. So I am discussing, like, speed is I am keeping normal because I am considering that few students are not good in mathematics, so I am focusing for them. And if you are good in mathematics, then what you can do, you can speed up, like 1.5x speed you can watch this video, or in 1.75, correct, if you are good in mathematics. Okay. But I am keeping those students in mind that they are not that much good in mathematics. Okay. Okay. So u into dv upon dx plus v into du upon dx. So this formula I will use. Here. Okay. So using this formula, what I can write? I can write as, if this is u, so u as it is, then derivative of cos x. Derivative of cos x with respect to x will be minus sin x. Okay, so I will write minus sin x. Okay, plus v as it is. V means cos x. So cos x you will see carefully, and derivative of u with respect to x. So derivative of x with respect to x will be 1. So 1. Okay. So in this way we will got minus x sin x. X into minus sin x is minus x sin x plus cos x. Okay. So this is our dy upon dx. So now we have to find the double derivative. So I will derive this function again. I will derive this dy upon dx with respect to x again. So that I will do in the next page. Okay, so now I am going to find d2y upon dx square, that is nothing but derivative of dy upon dx with respect to x. So in place of dy upon dx I will write as minus x sin x. This there will be, here it will be dy upon dx. So in place of dy upon dx I am writing dy upon dx, I am writing those values, correct? Okay, so in place of dy upon dx I will write as minus x sin x, minus x sin x plus cos x, minus x sin x plus cos x. And now I will derive this with respect to x. So if I will derive this with respect to x, then derivative of first term, that is minus x sin x, okay, and plus derivative of cos x with respect to x. So this minus is constant, so minus I can take outside, okay, minus I can take outside, this minus I can take outside, so minus outside I will write like this. Okay, so now again if you will see this is u, x is u, correct, and sin x is v. So I will use u into v formula. You can refer the formula which I discussed in the previous page. Okay, so I will use here directly u into derivative of v. Derivative of v means derivative of sin x will be cos x. So x into cos x plus v as it is, v means sin x as it is, and derivative of u. Derivative of u means derivative of x. So derivative of x will be 1. So 1. So sin x into 1 will be sin x only, plus this derivative of cos x. So derivative of cos x you know, minus sin x. Okay. So now you will, now we found d2y upon dx square. Just we need to simplify a little bit. So if I will simplify, then this is minus into x sin cos x is minus x cos x, and minus into plus. Minus into plus will be minus sin x, and plus minus minus. So minus sin x. So in this way, if I will solve, then I will get minus x cos x and minus sin x, minus sin x, minus sin x will be minus 2 sin x, minus 2 sin x. This will be our answer. This is our d2y upon dx square, because left side is that only. Okay, so this will be our answer. So I hope you understood. Okay, this will be our d2y upon dx square. Okay, so this was our question number 3. So question number 3 we have completed. Now we'll move to question number 4. So question number 4 is, we have to find the derivative of double derivative of log x. So in question number 4 y is given as log x. So in question number 4, y is given as log x, and we have to find double derivative d2y upon dx square. So first I will do dy upon dx. So dy upon dx will be derivative of log x with respect to x, and you know the formula that derivative of log x with respect to x will be nothing but 1 upon x. This is direct formula, correct? So I wrote the formula directly. Okay, now we have to find the double derivative of y, that is d2y upon dx square. That will be nothing but derivative of dy upon dx with respect to x. Okay, and in place of this dy upon dx you will write as 1 upon x, because 1 upon x you found as dy upon dx. So dy upon dx I am replacing as 1 upon x. I am erasing because of a space issue. Okay, if I will not erase, then I have to move the next page. Okay, so I am avoiding that. So d upon dx and 1 upon x, you don't know any derivative of 1 upon x, but 1 upon x I can write as x to the power minus 1. Okay, and I will use x to the power n formula, n into x to the power n minus 1, n minus 1, n value is minus 1, correct? So if I will write, then minus 1 into x to the power minus 1 is minus 2. So if I will write in simplified form, then I can write as -1 and divided by x square. Okay, so this will be our answer. So in this way we got answer as d2y upon dx square. Dx square is equal to -1 upon x square. This will be our answer. Okay, so I hope it is clear. The fourth one is clear. Okay, so now we are moving to the next question, that is question number 5th. Question number 5th is we have to find the double derivative of x cube log x. So y is given as x cube log x. So in question number 5, y is given as x cube log x. Okay, and we have to find the double derivative. So first I will find dy upon dx. So dy upon dx, derivative of this function x cube log x. Okay, so now here, since this is two functions, so this is u and v, so we'll use u into v formula I discussed on the previous page, so you can refer that formula. So I'm writing here directly u means x cube, u, and derivative of v means derivative of log x. So derivative of log x, you know, derivative of log x, direct formula, derivative of log x is 1 upon x. So this formula I will use. So derivative of log x is 1 upon x. Okay, plus v as it is, v means log x as it is, and derivative of x cube, you know, derivative of x cube using x to the power n formula. So 3 into n into x to the power n minus 1. So 3 into x to the power 3 minus 1, it means 2. So 3x square. Okay, so we have to write directly, otherwise solution will be lengthy. Okay, if you will solve each and every step in every solution. Okay, and x cube upon x is nothing but x square, correct, and plus this will be 3x square log x. Okay, so in this way we got dy upon dx as x square plus 3x square log x. Okay, so we got this as dy upon dx. So dy upon dx I will write here, and I will solve in this page only. So I am writing x square plus 3x square log x. Okay, this is my dy upon dx. Now using this dy upon dx, we have to find d2y upon dx square. So we will find d2y upon dx square, that is nothing but derivative of dy upon dx with respect to x, and dy upon dx is nothing but we got as x square plus 3x square log x. Okay, so you can separate the terms, the derivative of x square plus derivative of 3x square log x. Okay, and first one is clear. First one is very simple. X square derivative will be 2x, correct, and here 3 is constant, so 3 you can take outside, of the bracket, and remaining is nothing but u into v formula, again u into v. So you will use u into v formula, correct. So I am writing here, I will use this space, okay. So 2x also I am writing there only, so 2x and plus, now I am finding the derivative of x square log x. So x square log x, u into v formula, so u as it is, and derivative of v means derivative of log x is nothing but 1 upon x, just now we discussed, plus v as it is, and derivative of u means it will be 2x, okay. So 2x, log x into 2x. So if you will simplify this, what I will get? First is 2x plus I'm writing down, okay, plus 3 into x square into x will be x, okay, x square divided by x will be, x square divided by x will be x, and plus log x into 2x will be 2x log x, okay, 2x log x, okay. It will be 2x plus 3x plus 2x log x, okay. Now just I have to simplify, so I will erase this space and I will write here only, okay, because these all steps we did. Just now we have to do the simplification. So this is nothing but 2x, so I will write 2x plus 3 into x, that is 3x, and plus 3 into 2 into x log x, so 3 into 2, 6x log x, 6x log x. When you will simplify, 2x plus 3x is nothing but 5x, so 5x plus 6x log x, okay. And here you can take x constant, so x constant if you will take, then 5 plus 6 log x, that will be our answer. So I hope you understood. So in this video we have discussed the 5 questions, okay, of exercise 5.7, okay. So in case you have any confusion, you can ask in the comment box. I will try to answer that in the next video, okay. So thanks for watching and subscribe to our YouTube channel.